Hello, you absolute legends. My name is Don Kavanaugh, and let's talk about endothermic and exothermic reactions with respect to capital K. For any chemical reaction, or just a reminder, the general format is reactants going to products here, and capital K is a quotient of products divided by reactants. Let's look at one capital K value for a temperature, and then look at a second capital K value at a higher temperature, and ask the question, is it an endothermic or exothermic reaction based on the K values at two different temps here? Okay, if I have a K value, let's say at 40 degrees Celsius, and the K value is 2.9 times 10 to the negative fourth, and I have a K value at 60 degrees, let's say 6.8 times 10 to the negative 14th. Our K value changes with temperature, which is expected. It does change with temperature. If this is an exothermic or endothermic reaction, all right. What I suggest you do is you stick with one of these, predict both scenarios of exo and endothermic, predict how the K value will change, and see if it matches with the data. So right now, let's just recognize that this is a smaller capital K value, 10 to the negative 14th. If this is an exothermic reaction, heat is a product. If we increase the temperature of an exothermic reaction, more reactants will be produced. When we increase the temperature of an exothermic reaction, more reactants will be produced. This is Le Chatelier's principle. If R, the reactants, gets larger, then this quotient becomes a smaller value. If it's exothermic, the K value will go down as temperature goes up. This is an inverse relationship here, and this is what we saw from the data here, going from 10 to the negative fourth to 10 to the negative 14th at a higher temperature. Let's discuss the opposite, and that should be false with our data set. If it is endothermic, that means that heat is a reactant. An increase of temperature from 40 to 60 degrees would result in an equilibrium shift of more products being produced. If the numerator gets larger, the capital K value should get larger. And that is not what we saw from the data set right there. So this reaction is not endothermic. This reaction must be exothermic. I hope this helps. Thank you.